Cool. So in this video, we're going to do the first quantity, which is RSE, or residual standard error. So if you remember, when we're building our linear model, we said for each observation there is an error term that is associated with it. You remember that we had something like this. So the error term is just the actual y minus the predicted y. If it's sales of a product, it's saying the actual sales minus what we predict with our model. That gives us what? An error term for the ith observation, I equal to 1 up to the n observations that we have, right? So error terms make it impossible to perfectly predict y from our x because of so many error terms, right? So the RSE, it is defined as an estimate of the standard deviation of E. Yeah, it's defined as the standard deviation of E. We're going to see, like, in simpler terms what that means, right? So, like, roughly speaking, what this means is it is the average amount that the response will deviate from the true regression line. So when you say standard deviation of E, we're just basically saying, on average, how is the prediction or the response, let me say response, deviating from the true regression line. Okay, so how do we calculate RSE? RSE is calculated like this. RSE is equal to the square root of RSS over n minus 2. You remember our RSS. How do you calculate our RSS again? We calculate our RSS as the summation of yi minus yi squared. So this is going to be over n minus 2, because this is the calculation of RSS, if you remember in the previous videos. So that's how we calculate our RSE. And if you see here, we're sort of like averaging our e's, because these are going to be our e's, right? So it's a summation of our errors. We sum up our errors, and then we divide by n minus 2, which is sort of like the average, or like a mean sort of thing. So it's the average. On average, how is the prediction differing from? So it's the average of just these e's here. That is our RSE, right? So now let's look at, if we're looking at our advertising data, the result of doing this calculation, of calculating RSE, let's put it in a table like this. So the quantity, our RSE, it will be written like residual standard error. Our RSE is 3.26, and then we are going to talk about the R squared in the next video, 0.612, and this we'll talk about it later. Something called the F statistic. It's going to be 312.1. So yeah, our RSE is 3.26. How would we interpret this 3.26? I mean, how do we interpret this RSE? What does it mean in normal English? What this basically means is actual sales. So actual sales in each market, deviate from the true regression line by approximately 3 to 60 units on average, right? On average. So why 3,260 units? Is because when we calculate our RSE, we are subtracting yi minus yi squared, right? And these are in thousands. These are in thousands. So which means the RSE that actually comes out is 3.26 thousands. And 3.26 thousands, that is equal to 3,260 units, right? So your question would be something like, is this 3,260 an acceptable deviation from the true regression line? Well, it depends on the question. Here, if we are going to look at the cells, let's look at the cells, right? What is the y bar, which is equal to summation of y equal to n of yi divided by n, which is our y bar, right? Our mean cells, this is the mean cells units, 14,000 units. When you look at the data, just look at the data and then calculate the mean cells. It's 14,000 units, right? In all countries. So compare 3,000, the deviation 3,260 to and the mean. What is the deviation there? The deviation is 3,260, 14,000, which is approximately just 23%, right? So someone might say 23%, nah, that's okay compared to the mean of 14,000. Someone might be happy with that. So it depends on the task that you are doing there. Someone might say, nah, 3,260 is too large of a deviation, right? So this RSE, what it actually calculates is something called lack of fit, right? It's something that it calculates lack of fit. Why does it calculate lack of fit? Because if these predictors, these yi's, if these predictors, okay, that is the actual. If the predictions that we've made with the head here, if they are close to the actual one, if they are close to the actual one, it means this subtraction here will be a very, very small value, right? If it is a very small value and then we do square root and we average it, it means our RSE will be small. So what I'm saying is, if yi is approximately equal to the actual, it leads to a small RSE. Small RSE. And if it is small, then we might say what? The model fits the data well. I think that makes sense. If the RSE is small, we can say the model fits the data well. But if these two are very different, like we've predicted a value that is very, very different from the actual value, then our RSE will be high, and we might say, this model does not fit the data well. So we might say the linear model is too restrictive. It is not the right one to use here, right? So that is one way to measure the accuracy of our linear model. The next video, let's look at the other method, which is the R squared statistic.